So today is geometric sequence day. Woohoo! In a geometric sequence, the difference between consecutive terms is constant. The difference this time, though, is called a common ratio, which we've been talking about. And these are exponential patterns, meaning that we're multiplying. We don't want to say that we're dividing, because in your equation, you always end up multiplying, or you're multiplying by a fraction if you're dividing. So let's look at these examples. Which of the following are geometric? If the sequence is not geometric, is it arithmetic? A. So please talk to your neighbor. Is it, so you're going to tell them geometric, arithmetic, or neither? Who wants to tell me what it is? Finn, what is it?
Geometric.
Why?
Because it's multiplying by 2 each time. 3, 6, 12, 24, 48.
Great. Make sure you check the entire thing because it could switch up on you later. Am I supposed to tell you? Let's just go ahead and say what our common ratio is. I know I didn't ask for it specifically, but that's always a good thing to do. Times 2. Next. B. 3, 6, 9, 12, 15. Talk about it. What is it? Sophic, what is it? Why? Great. Arithmetic. Because it's adding 3. Great. So let's just go ahead and state our common difference is plus 3.
Not divided.
Okay, would someone please tell me what this one is?
Actually,
Elizabeth?
Geometric times 1/3.
Great. Because we're multiplying, it is geometric. Geometric. So your common ratio is times 1/3. Last one. Talk about it. This is disgusting. Plus 3, plus 4, plus 5, plus 6. It's deceiving. It's a pattern, but it is not a constant rate of change, and so it is neither. What you talked about yesterday, you might have been able to label some of this on your own already. G subscript 1. Think in your head, what do you think that means? Bella, what do you think it means? Yeah, it is. Right.
Oh my gosh.
This is the first number.
A little error.
Next up, we're going to point to R. Luke, what do you think R stands for?
R is probably the constant rate of change.
Which would we call that if it's a common ratio? What we're multiplying by. And the other thing we labeled yesterday was the N, which we have 2. What do you think N stands for? Owen, what do you think N stands for? What did it stand for yesterday? The term we want to figure out. If I'm like, find the 50,000th term, that's what you put in for N. Stand for?
First term.
Yep, again, G1, first number, or first term in your sequence. Next up, we got R. Oh, Mira, what does R stand for?
Common ratio.
Yep. And then the last thing we need to label is our N's. I'll make this, kind of crazy. Woo! Ellie, what does N stand for? Yep. before we do anything, we need two things. Tell the person next to you what are those two things we need always from the start. Okay, Pierre, what two things do I need?
The starting, the first term, and the common ratio.
Right. Look for the starting point, look for the common ratio. Ben, what is my starting number?
7.
Yep. So for this first one, I'm going to write that, not A1, because that's arithmetic. We're on geometric now. I'm going to write that, what did I do over here? I did it in red. No, I did it in, there we go. G1 equals 7. And my common ratio is what, guys? 3 multiplying by 3. So R is equal to 3. We are asked to write the recursive and explicit.
Yep.
Let's make sure we label what we're doing. We're first going to do the recursive formula, which is where I say, hey, here's my first term. So I'm going to write G1 equals 7, comma. Next thing I say is that G to the subscript N is equal to R times the previous term. So G subscript N is equal to the ratio 3 times G N minus 1. Do we know what N is? Did I ask you to find a specific term? No. So leave it as N. Again, do you know what N is? No. Leave it. G to the subscript N is equal to G1. Do you know what G1 is?
7.
Yeah, you do. So write it down. 7 times the ratio raised to the N minus 1. This should look really familiar. That's my first term. And then?
Comma, Gn is equal to 2 times G subscript N minus 1.
Okay. That is my recursive formula. Now I need my explicit, which I didn't leave myself very much room, so I'm going to do it like down here. Who's got the recursive? Thank you, Nancy.
2 times 2 to the N minus 4.
Excellent. Find the 7th term because it's after 6. Okay, let's look at these two sequences. We're writing recursive and explicit for each. The first one, 60, 45, 33, 75, and 25, 31. Would you please find your first term and your common ratio? Okay, I hope you can get your first term. It would be 60. Cora, what is my common ratio? 3/4. Because 45 is 3/4 of 60, 33/75 is 3/4 of 45, and so on and so forth. So you are multiplying by 0.75 or 3/4 every time. We'll finish that one in a second. Go to your second sequence now and find the same information for that. Find your first term and find your rate of change. Luke, what's my first term? And Sarah, what is my rate of change? Oh, not R. Bad. D. Because it's a common difference, not a common ratio. And this is arithmetic then. You need to write recursive and explicit for both of them. Okay, let's fix this. Because this one is arithmetic, I should have said A1. Thank you. Do you need me to go over how to put this in your calculator?
Wait, wouldn't it be 6, 7?
Let's fix that. There we go. That's the recursive, and the explicit would be and when you plug in, okay, there you go. So you want the arithmetic situation because then after 7 markdowns, it's free. Pretty good deal.